All right, continuing on with 5.7. Okay, in 5.7a, that's where we were solving out quadratic inequalities. Now, for 5.7b, we're going to be graphing these quadratic inequalities. All right, so now everything we've done up to this point with graphing, it's just going to change a little bit. Okay, just like when we were graphing linear inequalities, it just took another couple steps in order to graph this inequality. Okay, so we're going to use those same ideas still. So for the first one, we have a quadratic that is in standard form. So the first thing we need to do is we need to find the vertex. Okay, again, to find the x-coordinate in standard form for the vertex, negative b over 2a. So in this case, negative 5 over 2 times 1, which will give us negative 5 halves. Okay, so again, that's our x-coordinate. In order to find the y-coordinate then, you are going to plug that into the quadratic. So then we're going to have negative 5 halves squared plus 5 times that negative 5 halves minus 6. So a little bit more difficult one. Okay, so again, negative 5 halves squared. We're going to end up with a positive because we are squaring it. And what we do, square the top. So 5 squared, we get 25. Square the bottom, we get 4. Okay, so and then on the next one, plus 5 times negative 5 halves. So we're multiplying by a negative, so minus 25 halves. So 5 over 1, multiply fractions, you just go straight across. Okay, so then finally minus 6. So in this case, we have to get common denominators. Okay, so our common denominator in this case is going to be that 4. So we're going to keep that term the way it is. Okay, in the next one, we have to multiply both top and bottom by 2. Okay, because that'll get us 50/4. And then finally, think of 6 as 6 over 1. So we have to multiply top and bottom by 4 in that case. So when I do that, I'm going to get 24 over 4. Okay, now we can actually go through and do our subtraction. Okay, so 25 minus 50 minus 24 is going to give me a total of negative 49/4. Okay. Now we have our vertex. Now we have a vertex of negative 5 halves and negative 49/4. Okay. That negative 49/4, that's going to be around negative 12.25. Okay, so this is not exactly the best one for this one, but negative 5 halves, that is negative 2.5, and then negative 12, so we're just going to go somewhere here. Okay, so for this case, we're just going to find our x-intercepts. Okay, so typically, I'm going to want to see those 5 points. Test, quiz, you're not going to get one like this. But real quick, in order to get those x-intercepts, I'm going to factor up here. Okay, so in this case, x plus minus, I see I need positive 5x, so I'm going to make this positive 6, and that one negative 1. Okay, so that's telling me, again, x is equal to negative 6, x is equal to 1 when I solve. Okay, so I got intercepts at 1, intercept at negative 6. Okay, so we're just going to use those as our points. Now, this is where it changes between an equation and an inequality. Okay, if you remember, for inequalities, when it's strictly greater than or strictly less than, that is a case where we have dashed lines. Okay, so in this case, we're going to have a dashed parabola. Okay, and then the other part that came with inequalities was the shading. Okay, so again, in order to figure out where we need to shade, you need a test point. Okay, typically I'm going to use 0, 0. If that is true, we're going to shade inside the parabola. If that is false, we're going to shade on the outside. Okay, so plugging in 0, 0 into our inequality, so y is greater than x squared plus 5x minus 6. That's going to be 0 is greater than 0 squared plus 5 times 0 minus 6, which ends up being 0 is greater than negative 6. Okay, which is a true statement. Therefore, we have a true statement there. And again, we want the true area. Okay, so our shading will go on the inside of the parabola. Okay, so nothing really new there. Okay, you're still graphing the parabola, Now you just have to consider the dashed or solid for the parabola and then your test point to figure out your shading. Okay, so systems of inequalities now. Okay, again, systems, we're going to have multiple, okay, and then we're going to look for the overlap of the shading. So let's go ahead and in the first one, let's figure out our vertex. We'll do that one in black. So our vertex for that one, again, negative b over 2a. Okay, let's go ahead. Negative b over 2a, which is going to be 0 over 2 times 1, which is going to be 0. Okay, so our vertex in this case, x-coordinate is 0. And if you plug 0 into here, that's going to say 0 minus 9. So the y-coordinate would be negative 9. So we got 0, negative 9. Okay, let's go ahead. Let's do our table. X, f of x, a f of x, negative 2, negative 1, 1, 2. And we're squaring values. So 4, 1, 1, 4. And finally multiplying by 1. Okay, so the values stay the same. So that's saying left 2 up 4. Right 2 up 4. Right 1 up 1. Okay, so that is the 5 points we need for that graph. And in this case, it is greater than or equal to. So we're going to have a solid parabola. Okay, let's go ahead. Let's just go ahead. Well, let's wait to do our shading afterwards. Okay, so we're going to go ahead. Let's do this one in blue. We got our x coordinate of our vertex, negative b over 2a again. So negative 2 over 2 times negative 1, which will be 2 over negative 1 or negative 2. Okay, and then going ahead, plugging that back in to get the y-coordinate. You got negative 2 squared minus 2 times negative 2 plus 3, which will equal, that'll be negative 4 plus 4 plus 3, so a y-coordinate of 3. We get a vertex of negative 2, 3. Okay. Now, for this one, the only thing that's going to change is that the a value was negative 1. Okay, so negative 2, negative 1, 1, 2, 4, 1, 1, 4, multiplying by that negative 1, we get that. Okay, so instead of going left 2 up 4, we're going left 2 down 4. And then left 1, right 1, down 1. Okay. Now, for this graph, it is just less than. So in this case, we're going to have dashed parabola. Okay. So in this case, we can use that 0, 0 as our test point for both. So for this one, let's go ahead. Let's plug in 0. Okay, and again, look at the colors. We're looking at the x squared minus 9. Using 0, 0, we got 0 is greater than or equal to 0 minus 9, or 0 is greater than or equal to negative 9, which is a true statement. Okay, so since that is a true statement, we're going to shade on the inside of the parabola. Okay, now going to our second one. And we can use that 0, 0. Okay, when we plug that in, that's going to be 0 is less than 0 minus 0 plus 3. So 0 is less than 3. That is also a true statement. Okay, now for that one, the shading is on the outside. Okay, so again, we got, this was a true statement for that one, which is on the outside since we're looking at the blue. So we would look at shading the outside. Now remember, we're looking for where it overlaps. So I could go ahead, shade completely on the outside. You know what, let's go ahead, let's do that. We'll do that one in blue. We would shade the whole outside of that. And again, since it's a quadratic system, we are looking for where it overlaps. So where the green and the blue overlap, which is a little hard to see, but it would be this area right here. Okay, so that is where we would find solutions. Okay, and our test point 0, 0 is true for both, which is in that overlapped area, which it just tells you that that is the correct area. Okay, now let's go ahead. Let's get rid of the shading, and I'll show you the other way of doing that once it goes away. Working a little slow today. Okay, so again, on the black parabola there, okay, that was on the inside. So again, just going back to that arrows. So it's our shading for this system will be somewhere inside of that parabola. In that case, it's only going to be area 1 or 2 here. Okay, now since on the blue one it was on the outside, okay, that tells us it would be on the outside of this one. Okay, therefore where the arrows overlap, that would be this area here. Okay, so again, come test or quiz time in person if you would like. I got colored pencils if you want to use those. Otherwise, use the arrows. Okay, so that is 5.7b. Okay, so your homework is your 5.7b homework. Okay, you got 6 problems in there. Well, 9 problems, matching them up, and then 6 of actually graphing the system. If you have any questions, let me know. Otherwise, have a good day.